L'Hopital's rule, example 2, part C. All right. When we're taking the limit of a fraction, and look, you have the advantage of knowing this on assignment 40, that it's possible you might be doing L'Hopital's rule. But again, you always check for indeterminate by substituting in for x. So 0 plugged in for x right there. 0 squared is 0 times 5. That denominator would indeed be 5, or would be 0, pardon me. And this still has the potential for being indeterminate, but we check to see what the numerator is. And so if we put 0 in for x upstairs, it's back to that substitution idea. 0 cubed is 0, times 2 is still 0. Now we're thinking, what is the sign of that 0? So here we are again on the unit circle. 0 is our initial place, and the sign of 0 is indeed 0 times 4. That numerator, if you put 0 in for x, crunches out to be 0. Is this indeterminate? Yes. 0 over 0. Indeed, it would be appropriate to prescribe L'Hopital, whereby we take the derivatives of the numerator and denominator. The denominator is easy, that's 10x. And the numerator would be 4 times, ooh, this is chain rule, isn't it? Outside, inside, coefficient, chain rule. Let's see, what's the derivative of sine? Cosine, yep, cosine of 2x cubed. And then we take the derivative of what's inside, which would be 6x squared. And, you know, the interesting thing about this is that that numerator looks like it would be a product at this point, wouldn't it? And indeed, that might be interesting. Now, here's the error that I see quite often here, is to go ahead and stick 0 in and see if it's still indeterminate. This is one of the first examples we've seen. I think there was one a few back that had something like this. Before you go check for indeterminate, see if you could apply some algebra to this thing to simplify the expression. And the thing that I hope you would recognize with me is that that's 10 times x, and that's 6 times x squared. And the point would be, given the fact that the x here and the x squared here, those are factors, algebra says, indeed, they could be canceled. That's pretty important to notice here. And it would be easy to overlook that. And perhaps I should have been talking more about that on previous examples. But if you apply algebra to this thing, that denominator is 10, and the x cancels. So I hope you understand right along with me. That x canceled one of those x's, and so that x is gone, and that reverts to a single x. So we have our 4, we have this, and we have 6x. Aha. I hope you see that. So when you progress from one step to the next, always check if there's any canceling you can do using straightforward algebra. And that really made a big difference here, because after that x canceled with one of those, notice again, that denominator is 10. It's 10. And there's no x down there. And so putting 0 in for x doesn't do anything to the denominator. It's 10. So we're done with L'Hopital. That denominator is 10. Now it's just a matter of crunching it out and seeing what the numerator is. So you go put 0 here and here. All right, so I'll play the whole game. I'll go left to right. You might have noticed something that would make this quicker, but oh well. So we got the 4. All right, we put 0 in for x. 0 cubed is 0, 0 times 2, that's 0. Cosine of 0. Well, cosine of 0 is positive 1. So it looks like this middle expression would be 1. And then 6 times 0 is 0. If I'd have noticed that first, I wouldn't have really worried about the others. The point is, 4 times 1 times 0 is all 0. That's 0 over 10. And 0 divided by 10 is 0. Oh my gosh. So, always check from one step to the next. Before you go check for indeterminate, See if you can do any algebra to clean up your expression first. Had I not done that and done L'Hopital again, the numerator would have become the product rule, and it would have really stretched out crazy, and that would have been unnecessary. So always check algebra for cancellation before moving forward. All right, got about 3 more. Cool.